In this video, I will show you how to rough the outside using high-speed dynamic core mill. Dynamic core mill machines open pocket shapes or standing core shapes using the outmost chain as the stock boundary. The tool moves freely outside of this area. The inner chain defines the limit of the tool path. They are designed to utilize the entire flute length of their cutting tools to maximize material removal while minimizing tool wear. First, remove the toolpath display from your screen. To do this, press Alt-T on your keyboard. Now select Toolpaths, 2D High Speed, Dynamic Core. When the chaining dialog box appears, leave the default settings as shown. Select the following entity. Once complete, choose the OK button to exit the chaining dialog box. In the Chain Options dialog box, enable the multiple machining regions. Now click on the Select button in the avoidance regions as shown. Select the following profile. Once complete, choose the OK button to exit the chaining dialog box. Again, select the OK button to exit the Chain Options dialog box. In the Toolpath Type page, select Dynamic Core Mill. We will now choose a 1/4 inch flat end mill from the library and set the tool parameters. To do this, select Tool from the Tree View list. From here, choose the Select Library Tool button and then the Filter button. Select the None button and then under Tool Types, choose the flat end mill icon. Under Tool Diameter, pick Equal and input a value of 0.25 as shown. Once complete, select the OK button to exit the Tool List filter. In the Tool Selection dialog box, you should now only see a 1/4 inch flat end mill. Select the 1/4 inch flat end mill in the Tool Selection page and then choose the OK button. Your tool will appear as shown. Input the following comment and then select the cut parameters. For the approach distance, input a value of 0.5. Also, ensure that Optimize Cut Order Within Pocket is enabled and input a Stock to Leave on Walls value of 0.01 and a Stock to Leave on Floor value of 0. Finally, change the percentage of tool diameter to 500. I will now take a brief moment to explain a few of the parameters on this page. Step Over sets the distance between cutting passes in the X and Y axis. Toolpath Radius reduces sharp corner motion between cut passes. Micro Lift Distance enters the distance the tool lifts off the part on the back moves. Micro lifts are slight lifts that help clear chips and minimize excessive tool heating. Back Feed Rate controls the speed of the back feed movement of the tool. Motion, Gap Size, Retract controls retracts in the toolpath when making a non-cutting move within an area where the tool can be kept down or micro-lifted. And finally, Optimize Cut Order defines the cut order Mastercam applies to different cutting passes in the Dynamic Mill toolpath. Once the parameters have been adjusted as shown, select the entry motion. Entry motion configures an entry method for the Dynamic Mill toolpath which determines not only how and where the tool enters the part, but the cutting method machining strategy used by the toolpath. Ensure that the entry method is set to helix only. Entry method set to helix only creates a helical entry into the part. From here, select Breakthrough, enable this option, and input a breakthrough amount of 0.1. Finally, select the linking parameters. Ensure that the parameters appear as shown. However, change the depth to an absolute value of negative 0.125 as shown. Once complete, select the OK button to generate the toolpath. We will now verify the part to ensure that the tool motion is correct. From the Toolpath Operations Manager, click the Select All Operations icon. Select the Verify icon. Ensure that Tool, Stock, and Workpiece are enabled. Also, select the Isometric View and Fit icon. You can now press the Play Simulation button to run Verify. Your part will appear as shown up to this point. You can now exit Verify.